Hello students, secondary 1 chemistry. Now I'm going to learn you how to calculate the number of moles of any gas in terms of the volume of the gas at STP. If you know that 1 mole of any gas at STP occupies 22.4 liters, you can calculate the number of moles of any gas at these conditions. What are the conditions? STP, standard temperature and the pressure. The temperature of 0 Celsius or 273 Kelvin, and the other condition, pressure, air pressure or pressure of the gas equal to 1 atmosphere. These two conditions are called standard temperature and pressure. At these conditions, 1 mole of any gas occupies a constant volume called molar volume, and this molar volume equals 22.4 liters. This volume, which is molar volume 22.4 liter, is slightly larger than the volume of the normal football. This is the law used to calculate the number of moles. If you know the volume of any gas in liters at STP, divide this volume over 22.4, which is the molar volume of 1 mole. You can calculate the number of moles. Also, you can calculate the volume of any gas if you know the number of moles of this gas. Multiply the number of moles by 22.4, the molar volume. You can calculate the volume of any gas. There is a direct relationship between the volume of the gas and the number of moles, of course. As the number of moles increases, the volume of the gas increases, and vice versa. If the volume of the gas increases, this means that the number of moles of this gas increases. So this graph represents the direct relationship between the number of moles of the gas at STP and the volume of the gas at these conditions. That gives a straight line passes through the origin of the two axes. Here are equal volumes: 22.4 volume, 22.4 volume, 22.4 liter, 22.4 liter, and so on. This is the volume of 1 mole of any gas at this STP conditions. This 1 mole of oxygen has a molar mass 32 grams. This number obtained by multiplying 2 by 16, which is the atomic mass of oxygen. This is the atomic mass of helium. This is the atomic mass of the molecular mass of fluorine, 2 by 16, 2 by 19, 2 by 19, which is the atomic mass of fluorine, and this is the atomic mass of argon gas. At these conditions, 22.4 liter is the molar volume of 1 mole of any gas at the STP conditions. To solve problems, 1 mole of any gas at STP occupies how many liters? 22.4 liters. This is the answer. Half mole of nitrogen gas at STP occupies a volume of half mole occupies half of 22.4 liters, which is 11.2 liters. What is the volume of 2 moles of gas at STP? If you know that 1 mole of any gas occupies a volume of 22.4 liters, so 2 moles of any gas at STP also occupies 2 by 22.4 liter, which is equal to 44.8 liters. 2.24 liters of oxygen gas at STP represents how many moles. Divide this number over 22.4. This gives the answer, which is 0.1 moles. Divide this number over 22.4. This gives 0.1 mole of oxygen. Calculate the volume of 1 mole of phosphorus in the gaseous state and the gaseous state at STP. Then calculate the number of atoms in this volume. It's clear that the volume of 1 mole of phosphorus at STP of phosphorus vapor, the formula of phosphorus vapor is P4. So 1 mole of phosphorus vapor at STP occupies the molar volume of all gases, which is 22.4 liters. And the number of molecules of P4 in this volume is Avogadro's number, 6.02 by 10 to the 9 by 10 to the 23 power 23 molecules. So if you want to calculate the number of atoms, since one molecule of red phosphorus, of vapor phosphorus, contains 4 atoms, so the number of atoms of phosphorus is equal to Avogadro's number by 4. Avogadro's number. If you multiply Avogadro's number by 4, this gives you the number of phosphorus atoms in 1 mole of phosphorus vapor. Thank you for listening and goodbye.